Hello, and welcome to an introduction to audio programming, a presentation of the 1X Developer podcast. I'm Brendan,
And I'm Colin.
and we're doing a presentation on audio programming today. Um, Albert Einstein may have said, but probably didn't say, if you can't explain it to a 6 year old, you don't understand it yourself. Here at the podcast, we say, if you can't explain it after you've had a six pack, you don't understand it yourself. So
That's right.
we're
Did he not say that? Why do you say that? I've always been told that he said that.
when I looked it up, it was a little dubious. It
Mm.
was like there's no record of him actually saying that. It's often attributed to him, but like I don't know, we don't have real record. It's not
Mm.
like something that's in one of his books or something like that.
Oh.
You can fact check me on that, but I
Well,
don't
he
know.
mostly spoke German, right? So
Yeah.
he wouldn't have, might have said it in that way, but
It's often attributed to him, and you know, I think it's probably like the wisdom of the comment is true, right? It rings true.
oh yeah, I agree.
Um, but did he actually write and say those words? When I researched it, it was a little bit, I don't know, we're not quite sure. So, but the whole point of this presentation is that, I don't know, something like 10 years ago, I said, I like music and I like programming. How can I kind of combine these interests? And I really had no idea where to start, what to do. So this presentation is like a distillation of what I wish someone had told me at the time. Just the bare minimum to get up and running doing audio. Um, yeah, there's a lot. There are a lot of special things that are kind of like specific to audio programming, and so I just want to get you to the point where you feel comfortable, like kind of diving into the process. It's not going to be comprehensive. It's just kind of like the the basics.
And for the record, this is Brendan's presentation, and I am the mentee. I'm someone who knows basically nothing about audio programming.
Yeah, but I think that Colin is a really good audience for this because especially because of video game stuff, right? Like video games have a lot of interesting kind of restrictions with audio. They have a lot of specific, maybe I should say, requirements with audio. Like you need to talk about audio coming from like specific places in space, and that's its own thing. But it also needs to be real time. It needs to be keeping up with the graphics and things like that. Um, so I think you're a great audience for this.
Excellent.
So yeah, who is the aside from Colin, who is the other audience for this presentation? So I'm assuming that you're interested in music and or audio programming. I'm assuming that you have some knowledge of a DAW environment, that you've like recorded audio in Ableton or Pro Tools or GarageBand or something. You have recorded audio into the computer and played it back, basically. I'm going to assume that you have some basic coding knowledge. I tried to keep things really, really framework agnostic here, but at the end of the presentation, we do talk about we do go through some code examples, and I think that if you have some knowledge of C++, you'll be pretty good. If you understand like what just classes and member functions and things like that, if you're comfortable with that stuff, I think you'll be okay. We're not going to dive deep into like C++ internals or anything like that. And then we're going to talk about some math. We're going to talk about some trigonometry. Um, if you're anything like me, you haven't thought about trigonometry since high school. So I don't know. Hopefully, hopefully this is new. Hopefully this is information supplementing what you already know about trigonometry. I'm not the guy to explain trigonometry to anybody, but
I
um,
am hypotenuse, sine, cosine, etc.
Sokotoa.
Yeah. No, but actually, I actually did do a lot of trig in college.
Did you really?
Yeah, in electrical engineering, that's like a huge part of it.
Why does electrical engineering care about right angles? You know what I mean?
Uh, yeah, it's mostly the waves. It's the sine waves, the cosine waves, and then we do like Fourier transforms and stuff. We're transforming our waves. Yeah, I couldn't tell you anything about that. I remember. I feel like I might have said this before on the podcast. Like, I remember a calculus teacher saying that you really don't know algebra until calculus one,
Mm.
and you really don't know calculus one until calculus two. And I feel that way. Like when I started doing like calculus, I felt like that was when I learned trigonometry and I understood it. And then, but like the last class I took, I can't explain. Like I can't tell you what a Fourier transform is. I can't like you know. But I got good at the stuff that was required to be able to do that.
Yeah. Oh man, you're speaking my language. We're going to get into Fourier transforms, and I
Oh really?
will also not be able to explain them to you. But I'll be able to explain to you roughly how you can use them in audio programming. Um, we're going to talk about some practical aspects. We're going to talk about sines and cosines and all that kind of stuff. Um, but I mean, just enough to get by. I yeah. I don't understand that stuff well enough to really like explain it to somebody, but I think that I can explain it enough to help you get by.
Mm.
Yeah.
What was the
I,
Einstein quote again?
he said
Yeah.
something about a six pack. I don't know. So yeah, so what are we going to cover? We're going to cover the basics of sound. That's like sound in the analog, in the real world, and then we're going to cover how that sound becomes digital. We're going to cover, sampling and things like that. How analog sound becomes digital. We're going to cover how audio applications work in general. How audio application frameworks kind of help you out with that kind of stuff. We're going to spend some time talking about real-time programming considerations. There's a lot that goes on here with like why these are things that are kind of specific to audio applications because audio applications have to feel so responsive. Musicians use these; they need them eh, to feel like instruments. Really, they need them to feel like you twiddle a knob and it does something in real time. There's kind of a lot that goes into making that happen. Um, Computers are fast, but you need to you need to be very particular about how you're processing data in order to make them feel really fast, real time fast. And then at the very end, we're gonna create an audio application. We're gonna look at some examples of audio code. Um, I, I think I said I tried to make this presentation mostly kind of like framework agnostic, but we're going to be using the Juice framework, which is a popular audio application framework. Um, yeah, so that's where we're going with this presentation.
Is Juice available on everything?
Mac, Windows, and Linux. Yeah.
Is that everything? It's basically everything.
Are you running BOS?
Yeah.
Yeah, it's available on the major platforms, and I, my personal opinion, not having ever like done this professionally or anything like that, my personal opinion is that it makes it really easy to um, make one application for all of those platforms. It does
Nice.
a really good job of like, oh, I developed my platform on or my application on Windows, and now I want to expand to Mac. Like, it makes it pretty easy to expand into another platform.
Nice.
So, what this little drawing is illustrating is a waveform, a sound in the real world, right? How does a waveform hit our ear? How does a sound hit our ear? And what we're talking about here is basically oscillations of air molecules waves, these kind of waves can propagate through a lot of different mediums. Usually, when we're talking about sound, we're talking about sound propagating through air, um, through air molecules. But this is air molecules like vibrating back and forth, right? That's what creates the wave, and the wave kind of like moves through a bunch of air molecules, and then it hits our ear. And
Dude, you sound so smart when you say oscillations.
I I question myself. Is it oscillations or vacillations? I don't know.
I don't think I've even heard that.
I
Vacillation?
I actually don't really know the difference, but they're similar, but not exactly the same.
Yeah. But definitely between vibration and oscillation, you sound when you say oscillation, it's like, oh, this is a smart guy here, you know.
This guy knows what he's talking about.
Yeah.
Yeah, I appreciate that. Uh, yeah, so you have your air molecules that are, they're oscillating back and forth, um, and then that hits your ear. Your ear has, specific little the things to pick up the sound, and then your brain kind of interprets those things that it's picking up. Um, yeah, but the big part there is that there is there's a molecule, a movement of the air molecule that's like moving back and forth, and that's how it works in the real world. I think the point that we're getting to later on is that um, that continuous movement between, you know one extreme and the other is not, we can't represent that continuous waveform in the digital world. We have to like kind of approximate it. So we'll get into that in the next section. But for now, just understand that like, up and down and up and down, and then it hits your ear.
Hell yeah.
Um, we're going to talk a little bit about human hearing. We're not going to dive deep on this, but I think it's kind of important to understand this stuff when you're talking about audio in the digital world. Um, Human hearing is roughly in the range of 20 hertz to 20,000 hertz. So, there are frequencies that we can't hear that are above 20,000 hertz. There are frequencies that are extremely low that are not audible to us. There's just this range um, of vibrations that are audible to us, and it's something like 20 to 20,000 hertz. It gets less as you get older. You lose hearing generally on the high end. Um, we're more sensitive to some frequencies than we are to other frequencies. So, um, yeah, specifically around the 3,000 hertz range, there's like a kind of a spike in how sensitive we are to those frequencies. So it's important to know that if you're looking at a graph of specifically like how loud each frequency is within a sound, um, we we don't perceive those all the same. Some of them we
Right.
are more sensitive to than others.
There's a difference between the like true volume and the apparent volume.
Right. Yeah, exactly. And this gets into the whole field of like psychoacoustics and things like that.
Bro.
Um, it's yeah, there's a whole field of study of like how things appear to us versus how they are in reality.
All right, fun fact, dogs can hear up to 44,000 hertz,
Whoa.
more than twice a human.
I heard a rumor in high school. I have no idea if this is true, so I shouldn't repeat it. But there was an album that was out when I was in high school that supposedly had frequencies that only dogs could hear.
Mm, that's interesting. I remember kids, there was like this trend where kids would make their ringtone a super high frequency
Yeah.
because, yeah, the kids themselves could hear it, but the teachers couldn't hear it.
Were you not part of that generation?
I was, like, kids in my class were doing it.
Okay. And was that true? Could you hear it?
Yeah, no, it actually happened where so the thing is, it's a very annoying sound, right? Because it's like a really high pitched squeaking, and or not squeak, but just like a piercing like note, right? Like really high end frequency note. And so usually someone in the class would complain about it. And I remember there was a time where like some girl was like complaining to the teacher that someone's phone was making a sound or whatever. And the teacher was like, I don't know, they're explaining like, no, you can't hear it, but we can hear it. And it's like, she believed them, but I just don't know what I would have done in that situation. I'd be like, are you guys gaslighting me? Like
Right.
You want me to get after this kid when I can't even tell, like he's doing something imperceptible to me? Like, I don't know.
That's a perfect example. Yeah. Yeah. I remember that. I mean, I'm old enough that I remember hearing about that phenomenon, like on the news. Kids are using ringtones that are above the range of human hearing or like adult hearing, in order to like have a, get a phone call without their teacher knowing. And I was like, oh, that's wild. And I remember doing a test at that time. I was like, yeah, I can't hear it.
Yeah.
That's hilarious. That's a perfect example of what we're talking about here. Can only hear frequencies within certain ranges. There. Yeah. So I think that's, I guess that's the last slide. So yeah, in the next slide, we're going to talk about how those sounds from the analog world then become digital. We're going to talk about sampling and like how, analog sounds get into the computer, and then how we can do something with them in programming.
Hell yeah.
Cool. Catch you next video.
1X Developer Podcast.
Hey everybody, this is Colin. First and foremost, I want to thank you all for listening to this episode of the 1X Developer Podcast, and let you know that if you have any questions, comments, or if you just want to tell us about your day, you can reach us at X, formerly known as Twitter, at 1X Developer Podcast. We're also on YouTube at 1X Developer Podcast. You can email us if you're weird at 1xdeveloperpodcast at protonmail.com. And lastly, don't forget to follow, subscribe, all that stuff, so you don't miss any further episodes of the 1X Developer Podcast. Thanks so much. See you next time.
Mm-hmm.